Hi everyone, welcome to another video, and today we're gonna discuss about tree data structure. Tree comes in different flavors, right? The normal tree where every node will have multiple childrens, and then we have binary trees where every node can have only two children, and then there are binary search trees where the left children will be smaller than the node and the right children will be larger than the node, and so on. So today we're going to discuss about normal tree. So what is a normal tree? When we see a data structure where we have a parent or node, and this parent could have multiple children, C1, C2, C3, and so on. And every children is a node by themselves, right? And they can have their own children as well, like CC1, CC2, CC3. This might have CC4. This might have like three, like again CC5, CC6, CC7, and so on. So what kind of real world example we can find for this? For example, in your organization structure where we have a product owner, a product owner might have multiple managers under him, M1, M2, M3, and so on. And every manager might have multiple employees working from them, like E1, E2, right? This one might have E1, E2, E3. This might have E4, E5, E6, and so on. So this is a real life example of this kind of tree. So the normal trees are easy to implement. Actually, the node will be a node and children will be an array. Whenever we insert a value for a particular node, we just have to push the value to the children array, and every children is a node by themselves. They will have their own children as well. So let's implement the normal tree using JavaScript. So first we're gonna have a node that is basic node, and basic node will have like a val, like this dot val equals to val, and this val equals to, we're gonna pass the val, default value will null, and every node will have a children. And we're gonna initiate the children with a blank array. Let's create a method for every node, add and remove, so that it will be easy for us to write or add values later on. So we're going to create a method add that will take a value, and that will just push push the values to the children. Children dot push new node and well. And we're gonna also create a remove method that just gonna filter out the value. Well, and this dot children equals to this dot children dot filter like element, and we're gonna return element dot val not equals to 12. So children's spelling is wrong. Perfect. So now we're gonna create our tree class tree that will have a constructor, and this constructor will have a root. So this dot root equals to, if we are sending val here, then it can if val, right, val equals to null, default value null. If val exists, then it gonna assign a new node val. If not, we're gonna assign just null. The root will stay null if we are not giving a value. Now we're going to create a traverse function. This is the very important thing, because we're going to do here level order traversal, but later on when we are discussing about binary trees and all, we're going to learn about this kind of traversals in depth. But for now we have to go to every node of the tree, then our add and remove will become easy. So we're going to create a trav function that will take a callback, and then that will go through every node of the tree. And how we're going to go to node? For example, we're going to do it a iterative method. First let node equals to, we're going to put that in an array, this dot root, right, and we're going to create a while loop, while node dot length, let current equals to node dot pop. So it's gonna pop the value of the node, then we're gonna find the function. We're gonna call back the function, right? So cb dot call this dot current. So we're going to process the node based on our method that we passed, and then if node dot children, I don't think we have to do it here. And if children, then after processing this node, right, let children, these are children, we don't have to even check the children, we can just kind of push it. This dot node dot push car dot children. Yes. So it's gonna push the nodes. If we have children, so it's just gonna push. So now what we're gonna do is, using this traverse, we can create our add method or insert method. Let insert. We're gonna give an index. No, we have to give a value for some val, means the parent. We can create it parent, and the value we need to insert. So what it's gonna do is, now it's gonna call this dot trav, and we can write our method here. So every element will be every node, right? And if our el.val equals to parent, right, then we just have to el.add that val. We are using this add method so that we don't have to think about children that push and all. That's why we created this add method. We just can push use that add method here, and it will add the value to correct method. Again, we are doing yeah, it will create node here anyway. Same way you can create remove method that will give a parent. No, remove will not, we don't need a parent, we need a just a value. So whenever we need that value, it will just remove that node. So yes, so this dot trab, we're gonna again create a, we're gonna pass a callback, and in that callback, if no, we have to give a parent here as well, so that we're gonna give a parent a node, or we just can pass node as well. If we can pass node as well. But to delete, to remove it, if we pass just a node, then we have to keep track of the parent as well. If we pass the parent, then we have just to find the parent and remove it from its children. So let's pass the parent. So if el.val equals to parent dot val, sorry, parent is, we are passing the value, then el.remove that val. So we are just using this method to remove it. So this should do our trick, you know. Now let's go to test cases. So I'm creating a tree with node 1, then I'm adding to this one node, I'm adding 2, and then I'm adding 4. So our node will be 1 with 2 children, 2 and 4, and then I'm getting the root, because root is the value that will contain the node. And then we don't have a data, we converted into value, so let's make it val. So root dot value should be 1, and its children 0 should be 2, because it will create 2 children, 2 and 4. Now I'm inserting 2, for example, for I will traverse insert 2, 22 means it will find the node with value 2 and insert 22 to its children, and we're gonna check it by like root children of 0, then children of 0, val should be 22. Then we can again remove 2 from one's node. Now children of 0 will become 4 instead of 1, because at first time when we inserted 2 and 4, the value or root values, you know, 0th value used to be 2, but after we remove the 2 from the children, we should be getting 0th value 4. Now let's run the test cases. And it failed. Why it failed? Oh, we are not exporting, sorry. So module.exports equals to 3. Now why it failed? 3.add. Sorry, we don't have add method, we have insert method, right? So we will be insert perfect, should work. Perfect, everything passed, and that's how we're going to implement our normal tree. So thank you so much for watching.